Cool. Hello, everyone. Welcome to this live stream journey of an application from local machine to Kubernetes. I am Suraj Narvade, and in this series of live stream, we'll see how a app from your local machine will how a developer will develop an application locally, how to containerize it, and how to deploy it on production Kubernetes. So the whole journey, but we'll divide it into the parts and then we will go over it. Okay, so that's it. And okay, hi Pratik. Cool. So okay, so let's quickly start it, right? Let's hide this. I'll share my screen. So yeah, as I mentioned, the journey which we are going to cover, we'll give few minutes to so that people can join. Meanwhile, I'll introduce myself. So I am a platform engineer and I mostly work around containers, Kubernetes, and all this kind of stuff in day-to-day life. But I do love open source and DevOps and developer experience. One of the reason I did the series because I do like the developer experience aspect of the whole process because I have worked on few tools which enhances developer experience around Kubernetes. And yeah, for open source and DevOps, yeah, because since the start of my career, I have been in the DevOps phase only. So I do love. I do post YouTube videos around mostly around Kubernetes. My recent series is EKS Tells, which you can check on YouTube. Uh, these are my socials from wherever you are watching the stream because this is my first multi stream where I'm streaming to Facebook, YouTube, LinkedIn, and Twitch. It's just an experiment. But yeah, these are my socials if you want to connect with me. Okay. Agenda for today's stream is very simple. We will write a very basic Golang web server. If you are follow along with me or if you are watching this video after the live stream, you can like choose Python, Java, whatever language you want. It will be the same thing, right? So we'll simply write a Golang web server, and then we'll write a Docker file to containerize it, and we'll try to optimize the Docker file as well, right? So in this stream, I'm not going to explain what is Docker and like what is Golang. I'll assume that you know these basics, right? In some other videos or streams, we'll cover the basics of Docker as well. Okay, cool. So we'll do that, and next week in the next stream we'll do more advanced stuff such as adding the database for our application, or introducing Docker Compose, so how we can enhance the local development before reaching the production stage, which is Kubernetes. Okay, so let's quickly get going. Okay, so I already have Docker installed. Okay. Hi, Prashant. Prashant from LinkedIn mentioned I'm not aware of basics, so can you explain me? Yeah. So very quickly, go. I'll go back to my slides. So Golang, if you are not aware of Golang, it's just yet another language which I am familiar with, like like the Java or Python or anything, because I use Golang a lot. So I'll use Golang as a example in this stream. Hi Jitender. And for containerize it, when we say Docker and stuff, right, we'll use the same application to containerize it. Now, what is Docker? It's a bit broad term, but in short, it's a technology where you can package your application and deploy it on uh, either on Kubernetes or any container service, right? Now, because it's a packaged containerized format, it will work on your local machine and it will work similar on whatever production environment you have. So that's the whole point of the series, for showing the whole journey from like a local machine to the production cluster, right? So I hope that makes sense. In upcoming videos we'll do more deep dive at a basic level. Cool. Let's let's quickly delve into the actual practical, right? And before that, you can get the Docker for your local machine from the official Docker website. From this get Docker, you can like download on any platform that you have. I'm using Mac, so I already have Docker installed on my machine. So I'll show you that. So here, if I do Docker version and see, it is installed. In some other stream, as I mentioned, we'll go little bit low level and like do the installation and stuff. I hope this font is okay on streaming. Can someone confirm on the chat if that's okay? Yes, Aditya. Because this is a stream, it will be recorded and stored on LinkedIn as well as YouTube as well. Okay, perfect. So, what we are going to do is first we will write a simple Golang web app, right, and try to run it. So, in Golang, like usually the file name is main.go, and you will write package main. Now I will not go into language semantic because our focus is to understand the containerization process rather than the language semantic. Okay, so here we go. Okay, now for http server we will simply do http dot listen and serve. Will take port 8090 and this will be nil. Now once I do this, my web server will be up and running just like that. Okay, so but we need like something more, so I'll quickly add one more handler for this. It will be handle func. Don't get intimidated by the Golang. It's very very simple language. So func hello and w http dot response writer, and there will be a request which will be http dot request. Okay, and the very last bit, then we are done with code, will be if someone pings on this particular slash hello, what should we print? So we will say hello, it's Suraj in cloud. That's it. That's the code we are going to use today, right? Very 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 simple. Okay, why it is red? Because cannot use hello value of type w. Okay, something's wrong. So I already have a code here. I will just copy paste that code. Okay, this will be handle func. Okay, cool. So if you have any questions regarding this, you can ask me in the chat. But it's pretty straightforward. It's just a web server which is listening on port 8090, and if we hit slash hello endpoint, it will just print hello Suraj in cloud. Okay, so we have that now. So I will run the app to see locally what it does. Okay, now with go run, you can run the application locally. Okay, so now here, here, if I do local host 8090, we'll see hello Suraj in cloud there. Okay, now just for the understanding, I will add one more endpoint saying uh, world. Okay, and the function which we will execute will be world. Just add one more function, and this will be world, and here it will be world. Okay, now with this, okay, I will have to rerun my app again. And if we go to the application, slash hello is still there, but if we do slash world, it will be hello world, right? So it's just a simple web application. Now, as part of this journey of our application, as a developer, I wrote an application. Now I would like to containerize it, right? Now how can I do that? Okay, so the very first thing for containerization is to write a docker file. Now Docker file is just a format, where you will mention few steps, and when we will build the image, it will just build a Docker image which you can deploy anywhere. You can deploy it on local machine, you can deploy on production Kubernetes, you can deploy on Minikube, or you can deploy on ECS service, which is just container service. So technically, the problem which was there, the problem like it works on my machine, it doesn't work on your machine, that problem is not here. So if I build the image and give it to you, and you will also be able to run the same code without installing Golang or anything, just having a Docker, just run Docker and it will be there for you, right? So let's write a simple Docker file for it. Okay, now because this is a Golang application, we will have to use a Golang image. Okay, now where we will find the Golang image? Okay, this is my VS code. I will move it here. Now, on Docker Hub, which host all the images, like you can have your own account and you can host your own images, but there are few official images which you can use for basic application. Now, because my application is in Golang, I'll have to use Golang base image, right? On top of this, we will build our application. Now, on the home page, you will see this is Golang image. Now, one more thing I wanted to show you. On official Docker documentation, there are like various language specific guide. If you want to try out Node.js application, Python, Java, or Go, you can like go here and try out these applications as well. Like similar to what I'm doing with Go, you can do it with other stuff as well. Now, this part is done. Now, if we look here under Golang, there are, okay, description, there are various tags, right? You can pick any tag which is suitable for you. Now, ideally, we should use a tag. We should always use a tag. uh, But in this particular case, I'm not really focusing on the best practices. I just want to get something ready, and I'm not really deploying this on production as well, so that's fine. But in upcoming series we will see how we can make it like a production ready as well. Okay, so we will do from Golang, right? That means we will pick this particular image, okay, as a base. Now on top of this base, what we will do is we will copy our main.go, which was here, inside the image, right? What it will do, it will just spin up a container and like copy this main.go inside it. Now next step we will do, run this command. Now what command I want is, I want this particular command. Now what will this do is, oh, is screen stuck? Okay, let me see if I can do anything. This is me back and I'm sharing again. Hope that resolved the problem. Okay, I hope that problem is resolved. Okay, so I was doing go build. I can like what I'm trying to do is third step in the Docker file. Okay, cool. That's good. So third step I'm adding is go build -o app main.go, meaning uh, with Golang you can like compile a binary and like you can just run that binary anywhere, right? Uh, it's very different than Python. If you are familiar with Python, where you will run, let's say, Python main.py everywhere, like you cannot make, package out of it. Perfect. So I will run this command locally as well to show you how that works. Okay. So initially we run like a go run command which runs locally, but now we will build the app. Oh, what's happening here? Oh, on my local machine slash won't work. Okay, so my app is built. Now if we look at this app, it's a binary. Okay, and the permission, it will have like a plus x here because executable permission, right? Now instead of running go run, I can simply do app. Okay, and it will still run my application on the local host. I can do slash world as well, right? Cool. So basically, we wrote some code, we made some binary, we tested a binary as well. Now, in this Docker file, third step was we built the uh, what we built binary, and now the final step, how to run this binary. So there is a this new construct, cmd means command, how you will run this image, and we will run it as slash app, right? Like similar to what we did on our local machine, we wrote a file, we wrote a code in main.go, we built the binary out of it, and we ran the binary, we tested as well, right? We did that locally. Now we want to do it with container. So this is the few steps with which you can write a very basic Docker file. And now next we will build this Docker file, build the Docker image out of this Docker file, and let's run it and see if how that works. Okay, so to build the image here, okay, so to build the image, all we have to do is docker build hyphen t. Hyphen t means we have to give some name or image name. Okay, it will be Suraj in cloud, and we will, after colon you put a tag for this image. Okay, we'll just say part one. Actually, I will do this part one colon basic, and I will put dot. Dot indicates where is my code, like code as in we said, right? Copy main dot go inside the container, but where is that? So we will say it's dot means current directory. Now, and we are not providing like where is my docker file. If we don't, it will by default take anything which is with the name docker file in that directory. But if you want to be explicitly mentioned, you will say hyphen f docker file. Okay. Now it will build the image. Now when it builds the image, what it does is it pulls the library golang image, right, which we saw here. It pulls this image. Now on top of that, it adds my main.go from local machine to inside the container, and then it runs the go build, means it builds that binary, and then it builds the whole image. Okay. Now if I do docker image and this particular image, oh, I think it is images. Yeah. Right. So the image we built was Suraj in Cloud hyphen part one. Tag is basic and the size is 825 MB. Now the bigger size was because of the image that we used. Right. Now, how to run this image to test locally that whatever code I wrote is running fine. Okay. So we will try running docker run. Okay. I will do hyphen it means interactive, and I will give name of my image along with this tag. Okay. Now one more thing I'll have to do here is, because I'm running this container and I'll have to check if this is running, I'll have to map the port to my local host to see if everything is running. Okay. So for that, I will do hyphen p 8090 port of my local host and 8090 port of that pod. Okay. And now I will run it. Now once I run this application, now I haven't added any logs, so you won't see anything on the terminal itself. But if go to the my local host, we will still see the app is running. Okay. now now one more thing we can do is, how we can do that. Okay. Okay, yes. Now one more thing I would like to show is docker run with hyphen d. Means this container will run in background. Okay. With docker ps you can check that container is running and port mapping is this. Okay. Now instead of going to localhost, we will see the ip address of that container. Right now this is not important from developer perspective when you are developing an application and containerizing the application, but it's good to know, right? If you want to debug something at some point, so it's good to know. So let's search for IP. Now IP address is this. Okay. 172.17.0.2. Now if I put that IP address colon, oops, colon 8. Oh my god, what's happening here? 8. If I press 8, okay, so I'll just, okay, ideally this should have worked, but because the container and networking in Docker and on Mac is little bit weird, so I think it won't really work, but that's fine. That was just additional bit, but think our app is working now, right? Now I can push this image to the Docker registry, which is either Docker Hub K or whatever internal registry we have. Okay. And if you pull this image, it will work exactly similar. Okay. Now this is all good, but one more thing I would like to cover is, now, for example, I added one more endpoint here. Okay. One more endpoint, and I will say test. I will say test, and we'll just add one more bit, test. Okay, we will say hello test. Now I change my code, right? But I don't need to change my Docker file or anything. It will remain the same. Okay, that's the good part. And now if I Docker build again, it will again take some time and build it, right? And now if I look at my image size again it's at 25 MB. Now, considering the time to build and the size of image, it can affect the network transfer if you are, pushing somewhere or pulling somewhere, or like a building locally. This is just the basic project, but when you're working on like a more bigger services, those it might be bigger, right? And also, this particular Golang image, let's see what it's based on. Okay, so we'll just run that image and see what's in it, what this image is based on. Okay, I got the shell access, and if I do, because it's a Linux, right, I can do cat etc os delete. It's based on Debian. Okay, now if someone, now this Golang is based on Debian, right? That means my whole application container which is running is based on Debian. Now there are two problems here. One is the size, which is too big for this small application, and the second bit is, if there is an hacker or intruder, right, they can get the shell access and like do some malicious thing with my application. Maybe they will add some new endpoint to it, or like they might add, uh, is it running, uh, the application? Yeah, it is running. If you see here, Docker ps, the container is running. Okay, and if we still look at the local host, it is running, right? Now I was saying, like, I added this new endpoint. Now I will rebuild the image and do stuff, right? And I was mentioning the two problems. One was the, and the other one was the attack surface, as in, if the malicious user gets access, they have access to the that underlying Linux, and they can do some malicious activity. Now, to avoid that, what we can do is, to avoid these two problems, we can have multi-stage build. Okay. Now let's look at multi-stage build. Now, for multi-stage build, okay, I'll just have these setup. Okay. Same file, same everything, but in my Docker file, we'll introduce multi-stage and see how that goes. Now, in multi-stage build, what will happen is there will be two different steps. In one stage, we will simply build the image, we won't run, and in another, we will build the image. Okay, but this time, as I said, the second problem, the malicious user, we will use from scratch. Okay, from scratch again. If you go back to the Docker Hub, from scratch. It's a explicitly empty image, is the official image, and this image has literally nothing in it. Okay. And if we read, it does say that image is useful in the context of building base images. Okay. So it literally has nothing in it. Okay. So we will use this wise. It is pretty slim. And if there are some applications which are like, platform independent, just a binary, the scratch image is very perfect to run these kind of workloads. Okay. Now in our case, we are running a Golang web app, so it's perfectly fine to run it. Now, as I said, this here, that means we'll run it here. Okay. I'll just separate these two stages. Now, since we are building in this stage and running in this stage, this how we need to copy artifact from this stage to that stage. Now what do we mean by artifact? Meaning this binary, right? In this stage, all we need is binary, we don't need anything else. Because when you do this go build, it does like so many things, right? In the background, we don't need all that, we just need binary. So for that, in multi-stage build, what we will do is, for this stage, we will say as build. It's like a label on that stage. You can, like, instead of build, you can write whatever you want. And in this stage, we will say copy from where? From build. And copy what? Copy slash app. Copy where? To slash app. Okay. Very simple. And we will add one more stage saying expose 8090, because we are using that particular port. Okay. Very simple. Now, till now, what we did, I'll just do a quick recap. We wrote a very simple application. We ran it locally before containerization. We containerized it, but we saw there's two problem with that aspect, right? Though we are not really looking at Docker file practices, there's more to it. We can optimize even further, but we are looking at only two aspect. One is like the size of the image, and one is like not giving much attack surface to the malicious user. Okay. So for that, keeping that in mind, we'll just do this. Right. So as I said, multi-stage build, stage one, stage two. In stage one, we simply said, I want Golang image, copy this, build the Golang app. And in the second stage, we just want to run it, right? So the final image will be based on the scratch, simple and application, right? Cool. So let's build this image. Okay. Now this time I will say Suraj in Cloud part 1, and I will tag it as multi stage. Now if you see what happened here, it took that file, okay, from copied it, build it, and then in the next image it again copied that binary and then build the next image. Okay. Now if I do docker images Suraj in Cloud part 1, now you will see the massive difference which I was mentioning earlier. This was the first image which we built from the basic, you know, uh, what do we say? The from Golang, very simple Docker file. We did nothing fancy, and the size was 825, right? And if we look at the multi-stage we build, 6 MB. Now imagine the difference between 825 MB of an image and 6 MB of an image. When you are pulling the image or pushing the image or even storing the image somewhere, it's a massive difference, right? So it's very, very important to understand this bit. Now Because this is Golang image and it has like a binary. Now, multi-stage build can be different based on what runtime you are using. I mean, what language you are using. But the difference here is quite visible. Okay. Now, other thing is I would like to show is in my previous application, I can. Oh, what happened? Oh, there was a space. In my previous built image, I can take shell access and like do some things, right? But in my newer image, which was built on multi-stage, I cannot take shell access. Now, these things are good from security perspective because you cannot inside the container as compared to the previous one, right? That's what I meant earlier. But the other bit is when you are troubleshooting and like debugging an application, you cannot really go inside the application, inside the container to do some investigation. Rather, you will have to rely on logs. So in that case, our logs has to be nice and good and like it should be self-sufficient. So we'll see that in upcoming uh streams, how we can add like nice logs and make it reliable. But yeah, for now this difference is quite visible. Now let's run our newly built multi-stage image. Multi-stage. Oh, I didn't mention the port. Hyphen p 8090 8090. Oh, I cannot run it. Port already in use because the application is already running. Okay, so I will stop this application. Docker ps hyphen e. So I will now run this command to remove all the stale pod. Okay, I have all the there's nothing running right now. Let's rerun it again. It gave me an error saying exec user cause no such a file directory. Oh, because there is no shell, I cannot run it interactively. Okay, not a problem. We'll run it with a hyphen d flag. Hyphen d means daemon, it will run in background. Uh-oh, it didn't run. What happened? Interesting. If you are watching, if you know what's going wrong, do let me know as well. From Golang as a build, I'm copying the file, run go build from. Okay, that shouldn't be an effect, but okay, build, expose, and app. Okay, so that was all right. Don't know what's going wrong. Oh, yes. Docker always fails with the demo, right? It worked last night though. Sorry. Okay, so let's build the image again. Image built just fine. Now let's run it. Okay, 90 hyphen it part one multi-stage. Oh, Yes, Anjali, the session is recorded. It will be on LinkedIn as well and on the YouTube as well. Uh, I'm trying to figure out what's going wrong. Okay, if anyone has any tips what I'm doing wrong here, do let me know. Okay, something is going wrong for sure. From scratch, we just copied. Okay, I know what to check. So here in build go image, there is a multi stage section. Let's see if you are missing anything. Okay, so we did from Golang, we did from workdir. It's pretty similar, right? We are not changing anything. Okay, so let's try this workdir slash. Okay, and cool. Let's build the image again. See what happens. Oh no. Okay. This is so strange. Bit unsure why that multi-stage is not going good. No. Very strange. Let's solve this. Okay. We slash from slash to will say slash. Interesting. As build. Okay. Those who are watching, any clue what's going wrong? Okay. It's too strange. Don't know what's going on. What's going wrong here? Okay. So let's build it again. Docker build hive. Multi Suraj in cloud. Multi. Okay. And Docker run hyphen p 8090 hyphen d Suraj in cloud colon multi. Oh my god, this is not helping. There's something we are doing wrong, which I am not sure. Okay, this is bit weird. Okay, hyphen o yep, expose. Okay, and the scratch image does save this. I'm a bit unsure, but this should work. Okay, I I had one blog post written long time ago. Let's refer my own blog. Okay, that was multi must be here. Multi. Yeah, multi-stage build. Yeah, it's like 5-year-old blog, but still relevant. Okay, from an entry point. Okay, so what I can do is, let's, for simplicity, instead of scratch, I'll use Alpine. Okay, and entry point I will do, instead of CMD should be fine. Yeah. Okay, let's see. Sorry for that. Let's build the image. Now again, because we used Alpine instead of Scratch, there won't be massive difference in the size. Again, it's just 11 MB, right? I will figure out why the Scratch didn't work, but now I think with this Alpine, with Scratch the size was 6 MB, with Alpine it's 11 MB. Shouldn't be much difference, but yeah, our goal is to get extreme. I'll definitely get it running, right? But for now, let's just see how this runs. Okay, first I want port -it Suraj cloud multi. Oh no, what's happening here? Okay, let's do this. Instead of this, it's a entry. Okay, this is so weird. I don't know what wrong I'm doing. Okay, I think I need to just stop and get it working, and I'll show that in the next stream. But yeah, I think this is how you write the multi-stage build for sure. I'll I'll make sure this works, and like I'll publish the post and share with you all on the and Twitter. This is a bit embarrassing, but yeah, that's fine. It happens during the demos. But yeah, I think that's pretty much of it, the agenda for the today, which was we wrote some Golang web server code. We wrote a Docker file for it. We containerized it. We optimized the Docker image and the Docker file with the multi-stage. Sadly, we couldn't get it up and running, but hopefully next stream, definitely I will show. I'll figure out the problem and I'll show you in the next stream how that would work. Right. So yeah, I think that's pretty much of it. Hope you learned something in this stream. If you like this video, make sure you watch my other YouTube videos as well. If you have any suggestions, do let me know. You can reach out to me on LinkedIn, Twitter, wherever you want. But yeah, if you have any questions, you can put that into the chat. I'll be here for next 2 minutes, then I'll have to run to my work. It's 8:18 in the morning here, so yeah, after this I'll have to go to work. Cool. Yeah, is there any questions on the chat? Yeah, sorry for that last minute multi-stage build chaos. Yeah, we'll sort that out. Cool. If there any questions, any last minute? No. Okay, cool. Cool. Thank you so much for joining my stream. If you are late to the stream, you can watch the stream on either LinkedIn or YouTube. If you are not able to find the recorded session, do reach out to me for it. And if you have any questions and doubt, you feel free to reach out to me as well. And yeah, so let's end the stream here. I'll run to the work. Have a nice day. Bye. See you next Thursday for the next stream. Cool. See you. Bye. Have a nice day.